Good afternoon, everyone. Okay, please have your camera on. Any questions before we get started? I know that you did not have a homework for today. I mean, practice problems, but I hope that you guys worked on your Moodle for today. Any question before we get going?
I had a question over the Moodle homework, and it kind of resembled one of the problems that we had in the book.
Yes.
I'm sorry, I'm trying to pull it up. It's basically the if f of x equals x squared plus 3x plus 8. So remember we had that problem, but it was like plus 5, and then the average rate of change was f times t plus h minus f of t, and then over t plus h minus t.
Yes.
And then, so like for that one, it asks, you know, for the simplified version of it. So when I got all the way to the second to last, like, so the last two parts of that question is where I had like a little bit of issue with like just knowing how to, like, I guess, finish the problem.
Okay.
I agree with you.
Wrong.
I had the same issue.
Yeah.
All right, so just give me the problem and I'll go through it very quickly. If both of you had issues, so what was the function?
Okay, the function.
Each one will get a different one. So just give me anything you guys had.
Okay, mine was, okay, x to the second plus
Hello?
3x
yeah.
plus 8.
8?
Okay.
All right.
Yeah.
So
and then it was, oh, pretty much you got it. Never mind.
I know. All right. So first we have to evaluate each one by itself. Okay, just to make the problem a bit easier for us. So first I evaluate f of t plus h. Okay, so this is, as I said last time, part of this course is to learn how to do things in a more abstract way, which is important for us. So everywhere there is an x, we put t plus h. Everywhere there is an x, t plus h plus 8. All right? With me? Stop me when you, you told me you did that, so I think you're fine with so far. Then I have to take this one and expand it and combine like term. So if you do that in my memory, you should get this expression. You guys do it. Here I have to distribute plus 8. So I'm still computing this piece right there. So now if I put the whole thing together, the t square, I combine like term. So that's the t square. And then 2th, there is nothing to combine it with. Actually, there is nothing to do because no terms are alike. So it's going to stay the way it is. All right. Now, what is f of t? F of t is you plug in t for x. Okay. And now the problem that I think the part that you guys got confused with. So now every term is going to be substituted by its value. F of t plus h is, so this is f of t plus h. I'm going to write it down here. So that's t squared plus 2th plus h squared plus 3t plus 3h plus 8. All right, minus f of t is t squared plus 3t plus 8. Watch carefully. I put parentheses, I put a bracket to be careful. Now, t plus h minus t plus t minus t, they really cancel each other out. I'm left with h. Now we need to simplify this a little bit because it's a mess. So the only way to simplify it is, there is nothing to do here. I'm just going to distribute the minus. So I'm going to do that. plus 8. Now I distribute minus t squared minus 3t minus 8. The whole thing divided by 8. Okay, so stop me when you think you are having difficulty. Now, let's see if I can simplify some term. I mean, do some term cancel each other out. Okay, plus 8 minus 8 cancel each other out. All right, t squared minus t squared cancel each other out. Plus 3t minus 3t cancel each other out. Is there anything else? I don't see anything. So this is going to give me, that's my h. I will be left with 2th plus the h squared plus 3h. Okay? Now the last part is basically, can I a little bit improve that? So can I factor, the idea usually here, can I factor the h so I can get rid of it? Maybe yes, maybe no. But in this problem, we can, because my h squared here is basically h times h. All right? So I have the h in the first term, I have h here, and I have h here. So this tells me that I can factor out my h. And what I'll be left with? 2t times h, so that's the 2t which will be left. That's h times h. So I factor out the h, 1h is left. 3 times h, if I'm factoring out this, equal to 3. So basically, I'm doing the same thing, because if I multiply this out, 2th distribute plus h squared plus 3h. Now, h and h is a common factor for the numerator and denominator. As we talked about last time, that's the only time I can really simplify. So this I can simplify it, and I'll be left with that. Okay, question about it? Any questions? So for those who messed it up, I hope this will help you figure out what your mistake was. And anything else? Very good. So now, so I guess all of you can get hopefully this problem correct. Now I'm moving. Okay, today we're going to work with lines, and you're going to learn work with linear function. Definitely, I started lines last time. We talked about the slope, and today we're going to talk about the equation of a line. So, the equation of a line. Equation of a line. So what do we mean really by equation of a line? Okay, and I know that you guys have seen it, so I'm not really pretending you don't know that. All of us know that this famous mx plus b. So what my goal is today is one of the things, how can I get to this formula? And you're gonna learn two ways of getting to this formula. But before to do that, let's see what does it mean, the equation of a line. If you remember last time, when I asked you the following question, suppose you have a line, the slope is -2, that's the slope, and one point on the line, let us say, is 1, 4. Okay, this question we did last time. Can I sketch the line? I mean, is this information enough to help me to sketch the line? And we said, yeah, if you're going through the point 1, 4, so that's a point. That's the point. If the slope is -2, the slope is the change of y over the change in x, or what we called it last time, the rise over the run, which means that if I start at any point, if the run is 1, okay, it means if I move to the right by 1, I have to go back 2 units. So this is my delta y here, will become in this case the -2, which is the rise, and this is the run. That's my other point on the line. And my line would be exactly that. Okay. So knowing those two information, the slope and the point, I can sketch the line, which means that if I know what the line is, I should be able to find a formula that if I know the x, the formula is what is the y in terms of x? So finding the equation is basically finding the relationship between the x and y coordinate of every point on the line. So that if I know the x, I can find the y. If I know the y, I can find the x. So finding the equation is finding this relationship that exists between 2 points. Because 2 points, slope and a point, I know the line, so I should be able to find the equation. All right, so that's really what that means, the equation. Now, as I said, eventually we're going to get to this, but there are 2 ways we can get to that. And that's really what we're going to do. So the first way, how to find the equation, that's the first approach, how to find this relationship between the x and the y, how to find the equation using what we are going to call the point slope form. So we're going to use what we call the point slope form. So let's see what this means, point and slope. So suppose you have a line L. So L is a line, and I know 2 things about it. 2 things. M is the slope of the line. And I'm going to call this x0, y0, point on the line. So suppose I have a line and I know 2 things. As I said, if you know a point, you know the slope, you can sketch the line. So we should be able to find the equation. So this is my line here. I know a point and I know the slope. Okay, so the question is, how can I find the equation? Okay, the way we can find the equation is we're going to think like that. We said, okay, if I take any point on the line, any point on the line, any point. So I pick any point on the line. What's going to characterize this point? If I know the slope, this tells me the following. The change from here to here. Now what's the change from here to here? So y minus y0 over, if this is my x0 and this is my x, over x minus x0. So if the points, it means that y minus y0, just a change in y, over x minus x0, this should be equal to the slope. Okay. Now I'm going to multiply across by x minus x0. And this is going to give me what we call the point slope form. It means the form that will help me find the equation. So this is going to give me y minus y0 equal to slope x minus x0. And we call this the point slope form. The meaning, because if I know the point, I know the slope, then I should be able to find the equation that relate the coordinate of any point on the line. All right, so let us use this formula to find equation of only 2 lines. So equation, example number 1. So as I don't want to confuse you, eventually we're going to get here, but by using this form. So it's something that somehow you see, but we're going to use a different way. Actually, we're going to do it both ways, but that's the first one. So for example, suppose I tell you find the equation of the line. I'm going to use this form. So find equation of the line. I'm going to give you the slope. So the slope minus 2, that's a slope. And it goes through the point. I'm just going to come up with any point, 1, 4. Okay, so find equation of the line with slope minus 2 and go through 1, 4. It means I want the relationship between the x and y coordinate of every point on the line. And I'm going to do that using the point slope form. So now, how do we use it? The slope is minus 2. The point is 1, 4. So the equation will be applied like this. Y minus equal the slope times x minus x0. So in terms of the formula is y0 is the y coordinate of the specific point on the line. X0 is the x coordinate of the specific point on the line. M is the slope. So this is going to be written. This is minus 2. That's the slope. And this would be x minus 1, the point and the slope. So that's how we use this formula. Now, the only thing I'm going to be doing now is I'm going to do algebra to rewrite it in the format that you are familiar with. But that's going to be my starting point. So the way we're going to rewrite it in the format that you're familiar with, I'm going to distribute my minus 2 plus
Professor?
2. I'm listening.
I remember this seems familiar from a previous class. Can you put y and y1 instead of y0, or does it have to be y0?
No, those are names for the point.
So it could be y and y1 if I
don't
wanted
care
to?
what, yeah, whatever you
Okay.
want to call it. The book is
Okay.
calling them AB. I
Because I
thought AB.
remember this previously.
Sure, of course. I mean, you should. I mean, yes, I know. All right. So now we're going to solve for y. So we're going to add for both sides to solve for y. And that's would give me minus 2x plus 2 plus 4. It means the equation will become minus 2x plus 6. That's the equation of the line. Okay. So again, let us really emphasize what does it mean, the equation of the line, because we have to understand that. So the equation means that you have this line that I gave you, very specific line.
Excuse me, Professor, wouldn't it be plus 3?
Am I goofing? Very
Oh, you
possible.
distribute it. Never mind. Oh, sorry.
Okay,
Never mind.
thanks. Because I can do mistakes. So just say anything because, okay, I do mistakes for sure. So my line was, it passed through the point 1, 4. So this is 1, 4. So that's the point on my line. That's what I gave you. And the slope is minus 2. So if you go by 1, you go down by 2. So that's really the line.
Professor, I have a question.
I'm listening.
Why wouldn't it be negative 6? If you're are you adding the 4 to the 2?
Yes, why I'm adding the 4. I want to isolate the y.
Okay, thank you.
Okay, isolate the y.
Okay.
Okay. Thanks. All right. So now what's the benefit of this equation? Why having the equation actually is very good. So suppose I ask you find the coordinate of this point. So this is on this line. I want you to find this coordinate. What are those coordinates? So this equation tells you if you know the x, you know the y. So what are the coordinates of this point? My line is crooked, my apology, it should be straight. You can tell me the coordinate here. So that's the point, 1, 4. And we go by 1, we went down by 2. But that's not what, I'm going to use the fact that I know the equation to find the coordinate. Go ahead, what are the coordinates at this point? Anybody? Okay, let me ask you a question. What's the x coordinate of this point?
0.
0.
Would it be 0, 6?
Right. If this is the equation, it means if x is 0, the y will have to be 6. So I basically, okay, the y has to be 6. And this is what we call usually, if you guys remember, we call it the intercept. The vertical intercept, it means when the line is going to intercept the y-axis.
I'm sorry, this might be a dumb question.
There is no dumb question. Remember, I don't know you, so ask anything.
Okay, okay, well, now I'm starting to see why the y is 6. But I guess my whole question was, why isn't it that the y wouldn't be, or the y coordinate wouldn't be the entire equation where it's negative 2x plus 6?
Because yes, because this is a particular point on the line.
So if like they didn't put an actual point on the line and they were to ask us what's the y coordinate, then we would put the entire.
Exactly. But what if I pick it? So let me pick another point. So suppose I have any point, because that's really the benefit. Suppose I pick, I don't know what I want to pick, 2. Okay, suppose I pick this point, this one on the line, and I tell you this is 2. Forget about that. What's the second coordinate using the equation? That's really what the equation means. If I know the x, I should be able to know the y. If x is 2, what's going to be the y here?
2.
2, yeah, I plug in 2 for x, give me -4, -4 plus 6, it's going to give me the 2. Okay, so that's really about the benefit of the equation. Now I know the coordinate of any point on the line. If I know the x, I know the y. Okay, and that's really what the equation will do for me. So that's the general relationship between the coordinate of any point on the line. Now, if I zoom in at one point, then the problem will change. Okay, right. Example number 2, and then so example number 2 along the same line till we get this form going. So example 2, find equation of the line. Equation of the line. Again, I want you to use the point slope form of the line that basically I'm going to give you 2 points that passes through the point. And so let me pick 2 points. So let me say, for example, I don't know, 1, 4, that's 1 point. And the other one, I want it to be, let us say, I want to be mean a little bit, 3, not too mean, 3, 7. Okay, now 2 points determine a line. What do I mean by 2 points determine a line? If I give you 2 points on the line, so you can sketch the line. If I give you 1, 4, that's a point, and I give you 3, 7, that's another point. If I give you 2 points, I'm giving you the line. Another question is find the equation. It means find the relationship between any 2 points. Right. And I want you to use the point slope form. So the point slope form tells me the following. If y0 is any point on the line, x0, that's the form. So to be able to use the point slope, I need the slope first, and then I need a point on the line. But here I gave you 2 more than 1. All right. Is this an easy or a hard problem now?
Easy.
Easy. What's the slope quickly?
3/2.
3/2. So the slope is the change here over the change in the x value. It is 3/2. Done. I have my slope. Now I use the equation verbatim. Now I have 2 points on the line. In this formula, which point you want, I don't really care. You can use either one of them, regardless which one to use. You're going to get exactly the same answer.
Even number.
Usually, what?
An even number? Or does it not matter?
It doesn't matter. I don't care. With the one that you think is easy. Like here, I would rather work with 1, 4 than 3, 7.
Right.
It will be your choice. It doesn't really matter which one you pick. So I'm going to have y minus equal the slope x minus. I'm going to pick this point. So I'm going to say 1, 4 on the line. And that's the point I'm going to use. So y is 4, x is 1. Very easy way to find the equation of the line. Okay, I find it simpler than the one I'm going to do after that, the one that you're familiar with more. Now I have to solve for y. So I have it in the format mx plus b. So first I distribute. Be careful. First you have to distribute. It's going to give me 3 over 2x minus 3 times 1 minus 3/2. Now to isolate the y, I have to add 4, both sides. And that's what give me y equal 3/2 x minus 3/2 plus 4. Now, we never leave it like this. We have, of course, we have to simplify that. And how do you want me to simplify this term here?
Set 4/1.
What?
Set 4/1.
Yes, and then do what?
Add.
Find
Yeah.
Find the
Common
common
denominator.
denominator and then add it. The
Right,
top.
you have to find common denominator. So
Yeah.
that's going to become absolutely without common denominator. I don't know what to do.
Alright.
So y equal 3/2x minus 3 plus 8, because this is going to give me an 8, minus 3 plus 8, 5 halves. Equation of the line. Okay. So my lines has for equation 3/2x plus 5 halves. So now if I go back to the graph of my line, and I'm going to ask the same question as I did a minute ago. What's the coordinate here? What's the value here? It means when does the line intersect the vertical, the horizontal, the vertical line? That's the equation. What's this point here? Quickly. Just a
0,
little.
1.
No, absolutely not. Absolutely not.
My bad.
That's okay. I told you I don't know you. So just play on this. What is the x? So this is a point on the line. What's the x coordinate of this point?
That's not 2?
would be
No,
2.5.
That's 0.
that's
It's
0.
0, so y is 5/2.
Then y is what? Is 5/2. That's the vertical intercept.
Oh, okay.
Are that clear? That's the vertical intercept. This x is 0. If x is 0, the y have to be 5 halves. That's my vertical intercept. Okay. Questions before I move on? So, as I said, the goal is to learn how to find the equation of the line, and there are 2 ways we can go about it. One way is to use this equation, that's called the point slope form. The other way to do it is the way usually the students are more familiar with, and that I'm going to talk about it, is what we call the slope intercept form. So part 2 is use the slope intercept form to find equation of the line. So how to use slope intercept, and I'll explain where the word coming from, intercept, to find the equation of a line. So you can do 2 ways, and on the quiz, I usually ask you to do it both ways. So how to use the slope intercept to find the equation of the line. So first, I will tell you where is it coming from, and then we will learn how to use it. So what's the word slope intercept? The idea is that suppose I give you a line, and I give you the vertical intercept. It means I tell you where the line intercepts the vertical axis. And suppose I'm going to call this B. It means that the first coordinate is 0, the second coordinate is B. So that's the point B. And I give you the slope. The slope, it means I tell you that if we move 1 unit, how much we go. That's the slope. So I give you the slope, so I can draw the line. That's really what my line is. And the question is, what will become the formula? What's another form of the equation? Based on what I did before, suppose M is the slope. It's the slope. B, you should know what B is. B is right there. It's where the line intercepts the vertical. And suppose B is the vertical intercept. And sometimes people drop vertical, but I'm gonna vertical intercept. What does this mean? Vertical intercept means that the point 0B is on the line. That's what vertical intercept tells us. So suppose I have the line, and the vertical intercept is on the line. So what the equation will become? Now, if we use the slope-intercept form, if we use the point slope, the equation become y minus equal the slope x minus. Now, if B is a point on the line, it means this will become, I'm going to use the point slope form. Now, this is going to give me that y minus b equal m times x. I'm distributing. And this would tell me that y will have the form. So if I know the intercept, mx plus b. And that's what we call the slope-intercept form. So B in this format is this point right here, and is the slope. Okay. So now the question is how to use the form of the line to find the equation. So we have, as I said probably a million times by now, we can find the equation in two possible ways. We've learned how to use the point slope. Now how to use this one. I'm going to do two examples. The first one is straightforward. The second one is easy, but not straightforward. So example number one. Okay. Find equation of the line. Equation of the line. With slope that passes through. So I'm going to give you a point through, the point 0.04 and slope of -3. Okay, so find the equation of the line that passes through the point 0.04 and slope -3. So basically, what does it mean? What is the point here? 0.4 is basically the intercept. And -3, that's just the slope. So that's really my line. So find the equation. And I'm going to use the slope-intercept form. So the slope-intercept form tells me that y should have the form mx plus b. And in this particular case, m is -3. It means y should have the form -3x plus b. Now we need to find b. Did I give you b in this problem or I didn't? Did I give you b?
Yes.
Yes, because either you remember that b is 4, and if you forget b is 4, I don't really care. To find b, you say, okay, if y is 4, if x is 0, y is 4. So this means that b is equal to 4. Very simple scenario. So my equation is -3x plus 4. Okay? So the simple scenario, when I have the slope, I have the intercept, the equation becomes very easy. Now another problem is I'm going to do, using the slope-intercept, I'm going to do another exercise.
All right, can you just put that up for just another second, please?
Sorry.
Thank
So
you.
example number 2. Find equation of the line that passes through Okay. Are you guys done?
Yes.
That passes through the following point. I'm going to take the same point I took previously for the slope-intercept. So basically, I'm going to take those points, 1, 4, and 3, 7, the one I took before, and I'm going to find the equation again using the point slope. And we should get the same answer. So the points were 1, 4, and 3, 7. So find the equation using, the difference now, using the slope-intercept. Slope-intercept form. Very good. So what do I mean by that? What I mean by that is that, okay, the form tells me that y is mx plus b. So I need to find m and b. So first m is easy. M is the slope. It's the change, 7 minus 4, we did it a minute ago, over 3 minus 1, which is 3/2. Now we want to find the b. Okay, we want to find the b. I need to mute everyone. Okay, now I need to find the b. And the way we do it is that, okay, we say the relationship between, that's the relationship between the coordinate of any point on the line. B is my unknown, but the point 1, 4 is on the line. It means if I plug in 1 for x and 4 for y, this equation should be satisfied. And I use that to give me the b. So this will give me that the b equal 4 minus 3/2, common denominator, 4 times 2 over 2 minus 3/2. It means 8 over 2 minus 3 over 2. This is going to give me 5/2. So the equation will become 3 over 2x plus 5/2, which is exactly what we got before, because regardless how you find the equation, whether you start from the slope intercept or you start with the point slope, you're going to get exactly the same answer. It doesn't really matter what's your starting point. Okay? So when you find the equation, unless I told you which method you use, you're free to use anything you want. Most probably at the beginning, I will ask you to use both ways because I want to make sure you can use both of them. But the bottom line is, regardless how we find the equation will have the form, always the slope times x to the power 1, so the power of x has to be 1, plus b. That's really how it, regardless which method we use. Okay, based on this, I'm going to ask you 2 questions, which are the following. I'm going to give you a bunch of lines, and I'm going to ask you to identify the slope and the intercept. The question is, find slope and intercept. Intercept and sketch. We'll sketch some of them, not all of them. All right. So the first, the simple one. So we get going. Suppose I tell you y is 2x plus 4. Identify the slope and identify the intercept. All right. Anybody can identify the slope for me?
The slope is 2.
The slope is always what x is multiplied by. Always. X is multiplied by 2. That's really always my slope. My intercept. My intercept is what happened when x is 0. So if you always forget, intercepts what happened for x equal to 0. Well, what happened is 4. That's my intercept. Okay, so whenever you have equation of a line, yes. Question? Okay. Now I want to sketch. How shall I sketch this line? I want to do it in 2 ways. How shall I sketch this line? If I tell you sketch this line, how would you do it? Anybody?
You should put a point at 0, 4 on the graph.
Okay, I put 0, 4. That's my intercept. And then?
And then don't you go over 1 and up 2?
Okay, the slope is 2. It means if you go by 1 unit, you should go by 2 units. So this should be the 2 2 over 1, that's the slope, which is 2. That's my line. Okay. Now, what's another way of sketching the line? This is perfect. This is perfect. Or, because sometimes the slope is mean, it's 2/3. So what's another way to sketch a line? Or you just find 2 points on the line. If you know 2 points, you can sketch the line. So you can either do it this way, or, which is a lot of times, this second approach could be easier, or you just draw 2 points on the line. It means you take your graph, this is your function, 2x plus 4, and you find 2 points. Okay. You say, all right, if x is 0, it is 4, that's a point. Then you pick another point that you think is nice. It means you pick another value of x. I don't care what you pick. Suppose I pick x to be 2. You can pick 1. And this is 2 times 2 plus 4. That means this is 8. So now I draw the point. This is 4, so this is 8, makes sense. I draw another point. So this is 2. So this is my line. Okay, so you can do it either way, either like this, or a lot of time, believe me, you need 2 points. You find 2 points, you sketch a line. So either one will work. Okay. Now, back to the same type of questions, but I will not sketch now. I will just ask for the slope and the intercept. So B, suppose I give you y equal 6 minus 3x. My question is, what's the slope? What's the intercept?
The slope is -3
Do you agree with him?
over 1.
But yeah, you don't have to write 1. I mean,
Okay.
there's no point. So the slope is everything x is multiplied by. Intercept? What happened when x is 0? Intercept 6. Okay. Now 2 more questions along the same line, of course, with a little bit of a change. Sometimes the equation of the line is given to you not in this format y equal mx plus b, but in a disguised form. So for example, they give it to you in this form. Suppose I give you that. That's another way that I can give you the equation of the line. And now my question is again, how can we find the slope and how can we find the intercept in this scenario?
Don't we have to give y by itself?
Repeat, I couldn't hear you.
Don't we need to get y by itself?
Right, so we have to rewrite.
So wouldn't you just subtract 3x and 5?
We have to. Absolutely correct. We have to rewrite in the form mx plus b. So to do that, I have to subtract 3x. I have to subtract 5. Once I do that, the slope will be clear. And the intercept will be clear. So my slope now is -3. My intercept is -5. Okay, now one last problem along those lines. Suppose I give you 2y minus 3x plus 5 equal to 0. So what's the slope quickly?
Subtract 2y.
I wouldn't subtract the 2y because it's going to give me minus 2y.
You would add the 3x. To the
All right,
other
I will add 3x. It makes it a bit easier. And subtract the 5. So I will have the 2y. So I don't have to deal with the minus 2y. And then what I should do quickly?
You would divide it all by 2y. So
No, by 2. Divide by 2.
My bad, 2.
That's okay. Which gonna give me 3 over 2x minus 5/2. And now we're set to go. The slope is 3/2. And the intercept Okay, x is 0, minus 5 halves. All right. So that's how we find the equation of the line. That's how we identify the slope and we identify the intercept. There are a lot of other properties of the line, geometric properties, but I would like to do them next time. Now we're going to talk about linear function. So what is a linear function? So function is a rule. You give it an input, it gives you an output. So when I say that this function is linear, what do I mean by that? Linear function, okay? So as I said, linear function, it means you have a rule. You input something, it should output something. And I tell you that this function is linear. What type of information I'm giving you? The definition. We say that, oh, actually, definition. A linear function, so whenever I tell you it's a linear, is a function whose graph is a line. A linear function is a function whose graph, when you graph it, is just a line, straight line. In other words, when you graph it, that's linear, straight line. That's not linear. Once it curves, that's not linear. So linear, not linear. So that's, we're going to see 3 different equivalent for the interpretation of linear function. Now, if a function is linear, we know what the formula looks like. So if a function is linear, its graph is a line. So if the graph is a line, it means that if I know the slope of the line and the point, I know the relationship between the input and the output. Because for every x, I can find easily the y or the f of x. So the formula. So since the graph of a linear function is a line, then the formula for f of x is the equation of the line, has the form, so linear function, mx plus b. So I mean by that, that a linear function cannot have square in it. That's what linear function, it will not be linear, the graph will not be a line. So it's m times x to the power 1 plus b. So one straightforward example, which is the following, before we start actually understanding what's important about linear function for us, I mean, why they are so important. So suppose I ask the following question. Let f be a linear function. I'm telling you that f of x is linear. So the word linear here is absolutely crucial to the problem. And some values of f are given. I'm going to give you some values of f. Okay, so I'm going to give them to you the same format the book is using. So it's like this. These are input, and this is the output. Okay. And it tells me that if x is -1, f is 2, and if x is 3, the output is 6. So the way we read this, as you can imagine, it means we read that f takes -1 to 2, and f takes 3 to 6. Those are usually those input and those the output. So the question is, part A is, find a formula for f of x. Find a formula for f. Now, because it's linear, without the word linear, you look at me in the face, I cannot find a formula. I don't know how the function behaves. Because the function is linear, it means when I graph it, I'm going to get a line. So that's -1, 2, that's a point, and 2, So that's it, 2. 6 should be here. Means that's my function. That's really what my function is. And those are the point on the graph. So this is f of x. That's my function. Find a formula. It means give me the rule that if you know x, you know the output, f of x. So this really boils down to find the equation of the line that gives me, that connect those 2 points. So find the formula for f of x, right? Now say that f is linear. It means f is mx plus b. And now to find the equation, you can either use the point slope or the slope intercept, it doesn't matter. So first we're gonna find m, the slope, which is the change in the output times the change here. But now be very careful. This x is -1, so it's minus 1. 6 minus 2, it's a 4. 3 minus -1, it's a 4. So that's equal to 1. So that's the slope, that's the average rate of change. They all mean the same thing. Now we need to find the b. So that's my m. Now find b. So I'm using the point slope form here. Find b. I don't have the y-intercept. So I'm going to say, okay, I have 2 points on the line. I'm going to use one of them. So I say the point 36 on the line. Means the value of the function at 3 basically is equal to 6. So it means that, my function is m, which is x plus b. And now I need to find b. So it tells me that. Means if I plug in 3 for x in the formula, it's going to give me a 6. It means b is equal to 3. So the formula for the function will become x plus 3. So if I tell you the function is linear, then you can find a formula for it. If it's not linear, I have no idea what the formula is for the function. So now, suppose I tell you find f at 7. Okay. So I gave you the value at 2 points only. By telling you linear, I'm giving you the formula for the function. So now if I tell you find f of 7, will this be an easy or a hard question? What is f of 7 now? You plug in 7 for x. It's equal to 10. Okay, so now this is a function. And if I tell you linear, then we can find a formula for it. I tell you find f of 7. Now, since I have a formula for the function, f of 7 is equal to 10. So in the picture here, in this picture, if this is 7, what I'm asking you for is what's the output at 7? Since I have a formula for this function, the formula for this line, I plug in 7 for x and I get equal to 10. Okay. So finding a formula for a function which is given to you linear is actually finding the equation of the line that is given by the graph of this function. Now, question number 2 is in real life, is when our function like represent population, for example, what does it mean when you read a statement, the population is growing linearly? The question is, what does this linear mean in real life problem? Okay, so to understand what linear means, basically, you almost know what it means, but let us draw the picture again. So what does linear function characterize? So what characterizes linear function? What's about them? What's really make them? So what characterize linear function? What characterize them is the following idea that we've talked about, but now I'm just going to spell it one more time. If a function is linear and the graph is actually a line. Okay, so suppose this is my linear function. And and the graph is a line. And let us assume the slope is 3, for example. It means, what you guys know, means you start any point and you go by 1, you go up by 3. Okay. If you start here, you go by 1, you go up by 3. That's what characterizes it. It means that when the x value, if it's linear, when the x value increases by 1 unit, that's what linear really tells me. When the input, that's the x value, increases by 1 unit, the y value or the output, y value increases by the same amount, always, by the same amount. Okay, so when the x value increases by 1 in linearity, the y value or the output increases by the same amount. In other words, the rate of change is the same. Means the function changes by the same amount all the time. Or this is, that's what linear is. Now, if a function is not linear, it means it's curving, something like that. It's curving. Just by looking at the picture. If I pick this point and I move by 1 unit, the function is gonna rise a little bit. If I start here and I go by the same amount, watch what's the function doing. It does not rise by the same amount. So when linearity fails, the function does not grow by the same amount every unit of time. It grows that much, then it grows a little bit more. That's what curving will cause the function. So here the rate is not of change is not constant. It means it does not grow by the same amount every unit. It's not constant. Good. Okay. Yeah. So suppose now I give you a function, very simple, and instead of telling you it is linear, I'm going to ask you, is it linear? So instead of telling you linear, it is linear. So the question is, are the function below linear or not? And of course, justify your answer. Okay. And if I draw a line, it's linear. If I tell you that it's mx plus b, therefore it's linear. So now I'm going to give you a very simple table for the function. And I tell you, is this linear? So I tell you at 1, 2, 3, 4, minus 1, 6, 13, 20. Okay. Do you think this function will end up being linear if I graph it? Yes or no?
Yes.
Because?
It's increasing by 7 each time.
Right.
The slope is always the same.
Right. When the input changed by 1, so here it's very important that my change in x is the same. My change in x is the same. The question is the y value changing by the same amount? From -1 to 6, the change is 7. From here to here, it's 7. And from here to here, it's 7. So the delta x remained the same. So here, the change of y over the change in x is the same. It's equal to 7. That's definite linearity. If you have a table, is it possible to be linear? Yes. If the average rate is the same, then it is linear. So one more example. For example, suppose I x f of x. And let me come up with some number. 1, 2, 3. -1, 6. Quickly, who can give me a value here so that this function is not linear? 14. Okay, is this linear? The change here is 1. The change here is 1. So I kept the same change. From here to here, it's 7. From here to here, oh, it's 8. So the change is definitely not the same. So when x grow by 1, y is not growing by the same amount. It's not constant. Not linear. So linearity, it means something that grow by the same amount every unit of time. Okay, my last example is, suppose I'm not gonna give f to be this, the change in x to be 1. So suppose I tell you, okay, let me come up with some number, 0, 2, 3, and 3, 11, 50. Is this linear? So here I did not give you, the change in x is not really always 1. So in this case, how do we check linearity? So if the change in x is not constant, the same, to check linearity, we make sure that the average rate remains the same, or the slope is the same. Okay, so if x is between 0 and 2, from here, then the change of y over the change in x, because I did not give you 1, but still, the way you check it is you make sure to have the constant slope, is 11 minus 3 over 2, 8 over 2, which is 4. So from here to here, it's growing by 8. So the ratio is 4. Also, between 2 and 3, are we keeping? That's the only class where I have noise in the background. All right. Again, the change in y over the change in x. Again, here, it's 4. It is 15 minus 11 over 1. It's equal to 4. So if I don't give you the same delta x, to check that it's linear, you have to check the delta y over delta x. So now if I take and I graph it, you take this function and you start graphing, you have to get all those 3 points on the same line. That's exactly what will happen. Okay. All right. Now let us take problems, 2 simple or 3 simple problems where my function has a meaning. It represents a certain population growth and makes sense of everything in this idea. So I'm going to do a little bit worksheet. It is on Brightspace. And we're going to do those problems to bring the rate of change or the slope to life. So my first problem is the following. In the year 2000, so you guys have it on Brightspace in case it's not very clear here, the writing. Let me see if I can make it clearer. Okay. In the year 2000, the population of a town was 5,000. Since then, the population has increased by 50 people a year. And this increase is expected to continue. It means every year, 50 people. Let T represent years after 2000. And F is the function that is assigned. So now I have a function assigned to time, the population at time T. Okay, that's what F does. And the population T years after 2000. It means T equal to 0 will correspond to the year 2000. All right. So question number 1, fill in the table, which is an easy question. So at T equal to 0, 5,000. What's the population at T equal to 1? Very quickly. What's the population after 1 year? Put it on chat so I know everybody is with me. Nobody is answering. Do you guys know the answer? Okay, we're adding 50. After 2 years, we're adding 50. After 2 years, we're adding 50. So is the population linear, yes or not? Quickly.
Yes, it's linear.
Why? It's growing by the same amount. It's decreasing by the same amount every year. So now find a formula for f of t. Since it's linear, okay, we know stuff. We know that it's mt, because t is my variable, plus b. That's the form of it. What's the slope in this particular problem? What's the slope? I'm reading. What's the slope?
50 over 1.
What?
50 over 1.
1. You can either think about it, or you can say, okay, it's 550 minus 5,000 over 50 minus 0. It's 50 over 1, or just 50. All right, in this problem, do they give us the intercept? Do they give us b? Yes or no? Remember, b is what happened when t equal to 0. So are they gonna give us b? So f of 0 is 5,000. That's at 0. It means my b is 5,000. So my formula is f of t equal 50t plus 5,000. So, and on the graph, my 5,000 is here. That's my 5,000. And every year it's growing by 50. Every year growing by the same amount. That's my graph. And this rise is always 50. Identify the slope. Give it unit and explain its meaning. So what is the slope? Okay, the slope is the change per unit, which is 50. What's the unit of the slope? What's the unit of the slope? What does it represent?
People or population.
Not the complete answer.
The amount of population that it increased per year.
Per year, exactly. So it's going to be 50 people. What do you mean? 50 people is not enough per year. So the slope is how much your output, which is the population, increase per year. So whenever you think about slope, you have to think like this. When my input changed by 1, by how much my output changed? So the slope is 50 people per year. It means every year, not average now, every year, population increases by 50. 50 people. Every year, that's per year. So the unit of the slope is per year what's going on. All right, D. What will the population be in the year 2014? What are we supposed to do?
Did the graph start at 2000?
Yeah, t equal to 0 correspond to 2000.
I was just about to ask, like, if we can see how much more, like, which number represents what? I forgot.
Yeah, t equal to 0 correspond to the year 2000. And my question, what will be the population in 2024?
Would you do 50 times 24 plus 5,000?
Exactly. It means in 2024, the value of t, is you just subtract, is 24. So if you want the population, f of t gives you the formula for the population. So now at t equal 24, if you want the population, you need f of 24. It means 50 times 24 plus 30,000. Sorry, plus 5,000. And this would give me, that's what my calculator will help out. It's 50 times 24 plus 5,000. I'm getting 6,200 people. Okay. And everything makes sense because we're starting with 5,000. Every year we're growing by 50. Means in 24 years, we're going to grow by 24 times 50. So we end up with 5,000 plus 24 times 50. So linearity, the formula itself makes a lot of sense. E, in what year will there be 8,000 people only in the town? What am I asking you about now?
Would you subtract 5,000 people from 8,000?
Yes, but yes, you're right. But what are you setting up? Which equation you're setting up to do that?
$8,000 is equal to 50t plus 5,000.
Right. So we need to find t such that the population, but the formula that's governing the population is 50t plus 5,000 equal to 8,000. Okay. So what you said is correct, but we're trying to do it really. So we need to find the t. That's why when we find the formula, we can answer a lot of questions with ease. We need to find the t such that 50t plus 5,000 equal 8,000. And now I can solve. I take away 5,000. I will have 50t equal 3,000. Okay. It means my t, and I know that I have answers, is 3,000 over 50. Now, if you 3,000, it means give me 60 years, t equals 60. So the answer should be t equal to 0 correspond to the year 2000. So the answer will be in the year 2060. All right. So you have to set up your equation because those are easy problems for sure. But if the formula is a little bit complicated, we cannot guess. We just set it up. We're going to find the t such that this is equal 8,000. It means in the way scenario is, this is my output, and I'm finding the input that give me this for output. Okay, let's do another problem along the same, kind of similar. So I will do number 3 here. As I said, the worksheet is on your right space. I will skip number 2 because we only have 2 minutes to go. Okay, let's read this. In the year 2010, the value of a car was 30,000. Okay. And the value of the car decreased by 6,000 in 5 years. So it decreased, big deal. Then let t represent year after 2010. And let f be the function that assigns to t the value of the car t years after 2010. So my function takes for input years after 2010 and gives value of the car at time t. Okay. And what do we know about the value? So if I want to pick up a little bit, understand f of t, let's see what they are telling me. That's time, and that's the value of the car. That's my output here. T is time after 2010. So the initial value of the car is 30, so at t equal to 0. The car was worth 30,000 and decreased by 6,000 in 5 years. It means after 5 years, it went down by 6,000. So in 5 years, the value of the car now is 24,000. So that's what they are giving us so far. But then they tell me, assume f of t is linear. Find a formula for f of t. Without telling me linear, I cannot find a formula. Now they're telling me it is linear. Find a formula for f of t. So the car started at 30 and it's decreasing, whatever. So find a formula for f of t. Now being linear, it means my f of t should be equal to some, should have this form. That's the equation of the line. So now question to you is, what's the slope? Okay, what's the slope? I will take 2 minutes extra if you guys don't mind. What's the slope? Okay, anybody else? Not -6/5, change it a little bit. So let's compute the slope.
5/-6.
I don't know where you're getting 5/-6 from. Let's do it. What's the slope? You have 2 points. This is 1 point on the line, and this is the second point on the line. So what's going to be the slope? It's the change here minus 30,000 divided by 5 minus 0. That's a slope, the way you find the slope of a line, nothing changed. It means minus 6,000 divided by 5. It means if you divide 6,000 by 5, it's minus 1,200. That is my slope. So think about it as a line. We have 2 points. Please, question. So what they are telling you that in 5 years, it went down by 6,000. That's really what they are telling you. It means after 5 years, the value of the car came down to 2,000 to 24,000. So my slope is minus 1,200. So what is my f of t? So now my function is have the form minus 1,200 t plus b. Now we need to find the b. But I know that at 0, the value of the car is 30,000. So this is going to give me that b is 30,000, the intercept. So f of t is minus 1,200 t plus 30,000. Now, what's the unit of the slope? What does a slope of minus 1,200 mean in this problem? What does this number represent to you? Okay. So the slope is minus 1,200 what? What does it represent? In 5 years, the car went down by minus 6,000. And it's linear. It means it goes down by the same amount every year. So if the slope is minus 1,200, it means it's minus $1,200 per year. What does this mean to you? It means every year, the value of the car depreciates by 1,200. That's really what the slope tells me. So finding a slope means, I'm done, sorry for keeping you late. Finding the slope means asking yourself for every unit of time by how much your output is going to change. So it means changing $1,200 we're losing every single year. And that's really what the slope tells me. It's the change per unit. It means the change per year. Okay, sorry for keeping you 5 minutes extra. For next time, for Tuesday, everything will be written on Brightspace. You're going to have your quiz 3, which will cover average rate of change, line, and linear function. So do your practice problem. And then you will have a new online homework, but it will be due on next Thursday, a week from today. And remember that your online homework for tonight is due at 11:59. If anyone has any questions about anything, they can stay with me. For the others, I'm sorry about being 5 minutes late. You guys can go.
I had a question for the quiz. Which sections are they covering again?